Okay, so here's a lesson with a lot of vocabulary. Today we're talking about tangents. Now, a tangent is a line or a segment or a ray that touches a circle in only one spot. So here I have line TH that's a tangent to this circle at point H. It doesn't go through, it only touches one particular point. Now, we learned some really important things about a tangent. If a line is a tangent, then it's perpendicular to the radius. Now, you'll remember that a radius is the segment that connects the center of the circle to a point on the outside of the circle. So if the tangent is perpendicular to the radius, that means it forms right angles. All right. More information about tangents. If we have two segments from the same external point that are both tangents to the circle, then that means that these two segments are congruent. I know that because of the same reason that I knew that I was given up here, that if they were perpendicular, if a radius is perpendicular to a tangent, because if I were to draw that in here, I have a right angle, right? This segment is congruent to this one, right? Because they're both radiuses and all the radiuses are the same length. If I were to draw this line here, it would be equal to itself. So I have an angle side and side in order to have a congruence here, which gives me these pieces congruent. Now I know that we're not used to having a side-side. We do have a side-side angle congruence. And so that's where our corresponding parts give us that these two sides are congruent. So here we go, just a reminder. The radius is perpendicular to a tangent. So if a line is perpendicular, if a line is a tangent, it's perpendicular. If I have two tangents from the same point to the circle, then those segments are congruent. Now, if I have two tangent rays from a common external point, they're going to bisect the ray that goes through the center, the ray that comes from this external point through the center of the circle. The ray that comes from the external point through the center of the circle bisects this angle. That should also make sense as a corresponding part of congruent triangles, since we know that these two triangles are congruent. The converse is true too. If we know that these two are perpendicular, then we know this has to be a radius. If the segment on the outside is perpendicular to the radius, then this has to be a tangent. All right, I'm going to show you some weird pictures now. These two circles have two common internal tangents. Internal because they're in between the circles, and they've got a segment that joins the two centers, and this segment intersects the two tangents. These are two common external tangents. The line segment that connects the centers of these circles does not intersect the tangents, so they are external. I like to think of it as these are in between and these are outside. Now you see how these two circles are nested together? They are internally tangent segment circles. That means that they touch in this one spot only. And these two circles are externally tangent circles. Now, we're going to use all this information about tangents to determine a few things. All right, I've got a triangle here, and I'm going to tell you that AC is a tangent to circle B. The measure of angle A is 30 degrees. How can I figure out the measure of angle B? Well, what do we know about the radius and the tangent? That's right, they're perpendicular. So if this is 90 degrees and this angle is 30, then how much is B? You are correct. It is 60 because the three angles have to add up to 180. Okay, let's check out this one. In this particular triangle, I'm going to tell you that the measure of angle B is 65 degrees. What's the measure of angle C? It's not 90 because this is a chord, not a radius, so it is not perpendicular. Since these two segments come from the same external point,